Hello, we'll get started. Can you guys turn your webcams? Can you guys turn on your webcams? Everyone. Yeah, get started. Here we go. Jake, what happened to you? Okay. Anyways, one second. Sharing the screen. And the Zoom. Here we go. So, yeah, I know. Can't message you. You can message me now. Is there a test today or class tomorrow? Test? There's a quiz, but I don't know about the test. Okay, yeah. Which chapter? No, we were on the same thing going on. Yeah. Anyways, just wanted to add something since we shot in green screen. This is for those of you who, that is Vanidhi and Murali. Check this out, okay, if you're interested. We shot a lot in green screen, right? And you'll see what kind of stupid things can go wrong with green screen. And there's something interesting. You can check it out. It is a recent video by Tom Scott. Yeah. Anyways, how many of you got an answer for this? If I give you n-sided polygon, what is the number of sides? There's a pattern. You can observe the pattern and get the answer. I mean, like, what if the thing is made of 3 sides? Tell me, how much is this? How many other sides? 0, right? If it is 4, if it is 4, yeah, some of you gave the answer that day, but still, if it is 4, there are 2, and if there are 5, there are, I think so, if I'm not wrong, 5. Nah, not n by 2. What about 6? 9, I guess. Yeah, 9. So on. It goes on like this. The question is, what's the pattern? Yeah, 14 for this. What's the pattern? If I get an n, what is the answer? One possible way is guessing. You could keep guessing, okay, what the value could be. Has anyone figured out something interesting? Can anyone see anything interesting for that matter? If it is 8-sided, it's going to be how much? So none of you really thought about this. That's my conclusion out of this. Otherwise, you would have figured out something out of this. Yeah, Vivek found out something. Yeah. 21 or 20. Next is 20. Yes. Okay, so you guys have figured it out. You see the pattern is +2, +3, +4, +5, +6. Yeah, that is something you would have discovered if you had spent some time with it. Okay, like 5 minutes or 10 minutes, you would have seen that pattern. But the question is how to get it for the general case. Where's the 0.5 difference? No. The difference is about you're adding one value to it. Rahul, it's just based on basic things. I told you the syllabus, right? For the complex numbers test, you need to know conjugate. You need to know argument. You need to know what is modulus and how it behaves under multiplication. Multiplication, addition. That's all. You just need to know that. Okay, some of you Murali suggests using a recursive function. Okay, that's probably a method, one method we use. Avik has derived the sum of series 1 plus n, 2 plus 3 plus like this. Have you done it before? For general case? Have you guys done this before? Come on, 1 plus 2 plus. You knew the direct formula was n into n plus 1 by 2, right? Yeah, but there might be something. Yeah. So no polar coordinates, by the way. Nothing to do with this thing. What is that? Polar, this thing. Polar, this thing approach is not. The E power I theta is not the part of the syllabus. It's not there. So a lot of things are not there. You guys have derived. Okay. But can anyone figure out a formula for this? Like, I don't know. I'm not going to spend a lot of time on this. I gave you a day. Up to you guys. But the thing is, the reason why it was interesting for me personally is I derived this on my own when I was in 8th. Okay, it was fun. In the math class was going on, I was like, let me just derive a formula. And it was like, why not? It's fun. It's interesting. But the joy of discovering math on your own, like for example, figuring out that pattern, +2, +3. This is how math works. Math is not about solving those problems or whatever it's given in the test or whatever, nothing like that. It's just playing around. Okay, so try being mathematicians, not nerds, please. Okay, that's one more way of looking at it. Don't become those people who just solve something from the textbook and do stuff. Yeah, actually, most of you are like that here. That's what I've realized. You guys just solve textbook things and just, you know, close the book and you're then done with it. Like, which one? One second, I just saw it now. Shashank. Answer what is that? Okay, that's a lot. When you convert second order accounting, double counting, so you divide by 2. Yeah, that's one more way of interpreting Shashank. Yeah, Shashank's V's answer is kind of close. That's very close. That's doable. He gave an interpretation for it. His interpretation is, if I give you 4-sided polygon like this, like 4 sides like this, yeah, I know, Pratisha. 4 sides like this. He's like, each vertex will be connected to n minus 3 like this. There will be n minus 3 connections from each of them. From this also there will be one connection. So how many connections in this case? N minus 3. 4 minus 1. Tell me. Look, listen up. If there are 4 of them, how many connections will each one get? From each node, how many lines will be drawn to form a diagonal? If it is 4, it's 4 minus 3. Agree with me? No, it's 4 minus 3. It's only one diagonal, right? Agree with me on this? From each node, you'll be drawing one diagonal. Got the logic? Yeah, but then you double count, right? You end up double counting. You got the logic? So yeah, I got it. That's what Shashank is saying. So if you have, let's say if you had a 5-sided polygon like this, how many diagonals would you draw? Tell me, from each of them. One second. From each node, let's say you draw a diagonal. How many diagonals can you draw from each node? 1, 2. Agree with me on this? It's basically n minus 3, right? Agree with me on this? Can I get a yes or no? From each node, you can draw n minus 3. 2 diagonals. Okay. Now, the problem is, how many such diagonals can you draw? N diagonals. Agree with me on this? Agree with me on this? You'll be drawing n diagonals again, multiplied by n. If you want all the diagonals drawn, 1 times 5, right? Agree with me on this? Got the logic? Yeah, there'll be overlaps. 1 second. But do you agree that's one possible way of constructing? Agree with me on this? Can I get a yes or no? Forget the overlaps. From each node, we're going to draw 2 diagonals. So how many total diagonals? 10, right? Agree with me on this? That much you agree. I can draw 10 diagonals. But then I'll be overcounting. Do you agree with me on this? If I draw from this also and again from that back, I'll be overcounting. So you have to divide by 2. So you get 5. So the general formula is, if you have n-sided polygon, it's n minus 3 by 2. Do you see that now? That is the formula for n-sidedness. It's n minus 3. That's how many diagonals you can draw from each of them. Multiply. This is actually combinations. I know. You can think in terms of combinations. I'll come to that. But I've not taught you permutation combination. N minus 3 because I want you can draw 2 diagonals from each of them. You'll observe pattern wise. You can draw 2 diagonals from each of them. If it is 5, yeah, if it is 5, listen. If it is 5-sided figure, then you can draw 2 diagonals because you can't draw them to the adjacent ones. Agree with me on this? Look, each point has 4 neighbors. Agree with me? But those 2 neighbors are useless, like me. Agree with me? The adjacent ones are useless. Those form the sides. They don't form diagonals. Did you agree to the useless part being useless or the problem? I don't know. Any of them. It's fine. Okay. So you get the logic, right? There are 4 neighbors you can draw lines to. Okay, from a single point. But 2 of them are useless. They form sides. They don't form diagonals. So you ignore the 2. So it becomes n minus 3. Yeah. Yeah, no. I'm stating the obvious.
Sir, excuse me, sir.
Yeah.
I'm unable to chat with you, sir. Shall I leave and join?
Yeah. You log out and log in. Yeah, that's the order. Okay. Anyways, so everybody fine with the formula? No. It just look. You need to observe the patterns. Okay, just observe the patterns, and you'll see that. See, if you spend time with this, you would have figured it out by now. You would have realized this. So that you can draw only one diagonal for a 4-sided one. Got the logic, right? Can I get yes or no from everyone? What if it has 7 sides? And if it is let's say 7 sides, 7, 1, 2, 3, 4, 5, 6, 7. Now that's a terribly done polygon, but anyways, you see that I can draw 1, 2, 3, 4. Wait, is that 8-sided? Yeah, that is 8-sided. If it is 8-sided, let's do 8-sided because there are 8 points. If it is 8-sided, you'll clearly see that you can draw how many diagonals from each point. How many diagonals from each point? 8 minus 3, right? 5 of them. Agree with me on this? 5 of them. 8 minus 3. It's always n minus 3. 8 minus 3 from each of them. And then from each node you're drawing, so you'll get roughly about how many? 5 into 8. That's 40 diagonals. But then you'll be overdrawing them. So you need to divide them by 2. So you get 80. 20 diagonals. Okay. Yeah, even part. Okay, fine. So that's the formula for it. And I showed you the construction. We did this. We're talking about something. Remember that visualization where he took a piece of the square earlier? I'm teaching quadratic equations right now. So you can imagine what I'm going through. Okay. Yeah, I received a message on it just now. Yeah. Do you remember the difference in squares thing you did? Yeah. So one more thing I just want to add, that visualization part. I think Winton sir introduced this. I do not know. Probably he must have introduced this. The Trigonograph website, trigonography website. It's very awesome. It's proofs for simple things. What? I didn't get that. Was this done? Was this introduced by any chance? Trigonographs. These are awesome. Yeah. These are one diagram proofs. These are called, you look and answer. You look at the thing and then you know it is. Yeah. So this is a proof for the formula cos A plus B. These are proofs for the formulas. Yeah. Also, you might have seen this on trigonography. This is famous. This is a very famous problem. Some of you might know about this. What is x plus y plus z? There are 3 squares and lines are drawn like that. Now, question is, what is x plus y plus z? Yeah, some of you might know this. If you know this already, again, you're cursed. Okay. Like, you don't get to solve the problem. You won't get to enjoy the process of solving this. But I want to add a big but there. Shashank M, that's correct. Shashank V, that's correct. How much do you think it is? Take a guess. Some of you can take a guess if you want. When you add all the 3 values, how much do you think you might get? 0? How? Is something wrong with my screen? You're looking at the same picture, right? 180, 135, 90, 135. Yeah, many answers are there. 180 and all. Yeah, good. I won't tell you which one is correct for now. But yeah, there are multiple answers coming in. 100. Okay. Is it possible for you to look and tell? If you have that skill, that's crazy. That'll be one of the craziest things. Some of you are sure it's 135. Okay. Listen, one method is just take the image and join it together and check. I know it's simple trigonometry. Yeah, you can solve it in trigonometry. In fact, there are, okay, I'll come to this. This problem was there on number 5. Okay, and this is famous. Remember that lady I told you in the beginning who cracked, one of the 11 students who cracked that problem long back? Yeah. Listen to this, okay? I just want to show you. It's not angle chasing. No, angle chasing is stupid. Observe this. Angle chasing can be done, but you need to watch her roast trigonometry. Okay, she roasts trigonometry. Okay, you must understand that this is one of the Olympiad champions. And try, what's the solution? What's the solution for this? What's the solution? Can you see this thing? She has an accent, an interesting accent.
This is a 90 degree. Let's check. Oh, yep, it does look like 90 degrees. Okay, so now we truly believe the statement and we want to prove it. Well, the question is, at what level of your mathematical career or mathematical life you are? Because this problem has not only 1, not only 2, but at least 54 solutions.
It has 54 solutions, the math problem. Different solutions. Okay. And depending on, it's like basically a bag, it's a menu. Okay. You can actually pick which one you want. 15 solutions, 15 different solutions. Okay. And she does the most beautiful one. You need to observe this.
Are you beginning to do all of them?
No, we will do the most brilliant one, the most simple one that a fifth grader might be able to grasp. So the idea of our solution, at least the attempt when we cut with scissors, can be carried forward mathematically. So we may want to move all three angles into the same geometrical.
I heard that. I'll try my best to switch on so-called geo. Hopefully, is there a lag? Like, how bad is it? I just need to know. I just need an idea. Severe, it's fine, bearable. Yeah, roughly about 90 degrees. She feels it's about 90 degrees. No, look at, see, the reason I'm showing this video particularly, look at the way she approaches it, okay? Look at the way she approaches like a fifth standard kid rather than a mathematician who's an accomplished professor, okay? She doesn't like trigonometry. She doesn't like calculus. That's my point. Now, I know most of you are excited about calculus because that's new for you. But to me, if you come and ask personally about calculus, I'll be like, calculus is stupid. It's boring. It's for losers, I would say. And she also says that it's for losers, calculus and trigonometry, because it's not fun. It's really not fun to do it with trigonometry. It's boring. It's just equation scribbling and you get the answer. It's like not much. But you will start developing that attitude later in life where you start realizing that all of this is boring. I think if I don't know her name, I can't pronounce her name. If you're asking me for the name, I don't know if I can. Yeah, read it. Just read it off. It's here, the name. Okay. You can give it a shot. You say you prefer something over calculus. Yeah, linear algebra. I prefer linear algebra. I love it. It's awesome. That's right. You can always do, you can forget calculus. You can throw it out of the window. You can burn a calculus book and still be fine. I'm just saying. Okay, that should be the first thing you should do in linear algebra classes. In fact, that is what I motivate when I teach matrices in the first year, in first PUC. Yeah, she solved the IMO problem, the hardest IMO problem in the awesome way. Yeah. Anyways, I'll just show you the solution. Look at this awesome thing. Okay.
Location in our picture. So we need to find the best geometric location where to move those three angles. Well, there is no best geometric location until you know what the solution is. So we might as well just try to move them all the way in this corner next to gamma. Because we already have a right angle here, this guy. We have gamma here, and so the other two angles, alpha and beta, must somehow fit. And here comes the brilliant idea of this solution. As I said, there is something missing in this picture. What's missing is half of the picture. We will replicate these three squares up, and then we'll start seeing the truth. And now I think I'm going to start labeling things so people can refer to them later on. I'm just labeling all of the important and E. Well, for kind of case, alpha was bigger than figure out where did we see?
She does a small construction where she adds more squares and then connects the dot to the top. Do you see something now? Do you see something interesting? Yeah, you should be able to see it. The interesting thing here is, I think, no, she's just extending to prove the result that it's actually 90 degrees. She'll prove it. That's 90 degrees. Okay. But look at the way she does it. Do you agree that this angle here, HDI, can you see angle HDI? What do you think that angle is? HDI. All she did was she added three more squares at the top and then joined the points. Fine with this. She added three more squares at the top and then joined the points. What do you think is this angle HDI, roughly? Look at the number of squares it covers. It's very easy to see. How many squares, if you do half into breadth into height, do you see it as beta? Can you see it's beta? It covers two triangles. It's a diagonal of a two squares. It's a diagonal for two squares here also. This is also a diagonal of two squares. Can you see HD, the line HD is a diagonal of two squares? Agree with me on this? Yeah. Similarly, can you see that same diagonal here at beta? E to C, that drawn from E to C. Hope you can see that. Similarly, can you see the same diagonal drawn from E to H? Yeah. So you can see that this triangle here is actually isosceles immediately. It's actually isosceles. The green triangle that you see instantly is isosceles. Yeah. And then she starts arguing that this angle here, EHF is beta. Okay? EHF is beta. Since EHF is beta, so is HDI. HDI is beta. Okay? But since this is beta, do you agree DHI, listen to this, DHI is 90 minus beta. Do you agree with me on this? One second. I'll take a screenshot if possible of this. I don't know if I can. Wait, I'll just give it a shot. Print screen. I turned off the captions. But 1 second. Give me a moment. Okay, I think it's here. Scroll down, come on. Yes, I got it. Okay, so can you see this? Can you see the figure? Can you see the figure now? It's there. Can you guys see the figure? Yeah, good. So do you agree that this here, these two sides are equal first? Do you agree with me on this? Can I get a yes or no on that? Yeah. Next thing you'll observe that this here is beta. Agree with me on this? That these two angles here are beta. Because they form the same triangle in both the places. This is a knowledge you learned in similar triangles, guys. They look similar. So those angles must be same. That's the point of it. Your ability to observe that they're similar. It's two this thing, side length of 2. But you get the logic, right? You got it that this is beta. Happy with this, that it's beta. They're congruent. They're congruent also, not just similar. They're congruent. Yes. If you understand that they're beta, this is 90 degrees. So do you agree this is 90 minus beta? Yeah. Since that is 90 minus beta and this is beta, this here should be 90 degrees from 180 degrees. If this is 180 and two sides are equal, do you agree this is 45? These two are 45. No. What is done is basically a construction from E to H. A construction was done, and this was the only part. She adds extra portion to this thing. She adds another piece to the top. Yeah. So since this is 45, but this is 45, right? Agree with me on this? Since this is a square, this is alpha. So this is alpha, done. So alpha plus beta plus gamma is 90 degrees. Hope you guys are fine. Beta is not 45. Beta can't be 45. But alpha is surely 45. Beta can't be 45. Beta is not part of the, this is a diagonal of a square base, alpha. So it should be 45. Alpha is 45 because it's a diagonal of a square. Can you see? Alpha is a diagonal of a square, right? Like this. So this should be 45. Diagonal of a square makes 45 degrees. Fine with this? Yeah, it's a beautiful proof. The point is, I wanted to show you the excitement she has on her face when she solves this. It's even though it's like, you must understand she's an Olympiad topper, okay? One of the top mathematicians in the world. This is better than using trigonometry. I know, this is always better than using trigonometry. Beta is roughly 30, but then, yeah, you can prove it. Please check out that video. It's slow, but I recommend you guys check it out slowly on your own. I recommend it a lot. Like, she does the proof.
So I'm going to mark them in blue. So these two sides are hypotenuses of two right triangles.
But I recommend this one next, okay? Personally, this miraculous proof, Ptolemy's theorem. Okay, how many of you have heard of Ptolemy's theorem here? I'm not going to optimize because it's fine. The lag is horrible, I know. I will do something else. How many of you have heard of Ptolemy's theorem? You guys have to check this out. It is 38 minutes, okay? And she roasts trigonometry in that entire video from this end to that end, okay? She's like, trigonometry is for losers, okay? You will see it, it's awesome. It's a beautiful proof using something called a technique called circular inversion and geometry, okay? You can read it here, Ptolemy theorem, P silent. Although in my name it isn't, but yeah. Anyways, a P is silent here and it's Ptolemy, okay? So just look it up. This is beautiful and you can check it out on your own if you're interested. Okay. Wasn't Ptolemy an Alexandrian general? I don't know, guys. My social science, I forgot it the day they told me to forget it. Yeah, the 10th exam, and I was like, namaste, bye-bye. Okay. That was the last day I even thought of it. I remember the day I said goodbye to chemistry. That was the best day of my life. Okay, the best day. No offense, Murali, I'm sorry. No offense. But that was the best day of my life. The last exam. I still have it in my diary, written down in my diary. The last chemistry exam of my life. Hopefully. I was scared that I might flunk. But anyways. Yeah, anyways. Oh, my internet is unstable. Damn it. Okay, one second. I'll try switching. This might work, might not work. Give me a moment. You see the proof till then.
FH and HID, the ones which I drew in blue. Well, they are right because they have a right angle here coming from top. But they are also exactly the same size and shape. This right triangle has one leg 2 and the other leg 1. And this one also has a leg of 2 and leg of 1. Which means that they are third size.
I'll just try doing the switch. Hopefully I'll get it. What about the cyclic quads thing? Oh, no, that is awesome. This second one is epic circles, but the first one is, you need to check. It's called circular inversion. I don't know whether you guys have learned circular inversion, but it's a beautiful technique, circular inversion, where distance formula breaks down completely. I teach it in complex numbers, but right now, for you guys, it'll be too advanced, so I skipped it. It's beautiful though. Check out circular inversion if you're interested. Yeah, in complex numbers, I did narrate the history. The history part of complex numbers is super important to understand, the gist of it, why it works. Okay, anyways, I'll just go around. Oh, we're not done. So going back to this guy, 3 Blue Unknowns video, what he does is, now, I know some of you are going to be acting around like, sir, this is obvious, this is too easy. Okay, I know this. Yeah, I know you know it. I hope you can see it also. But you need to understand it's beautiful. I'll tell you why, okay? The concept which 3 Blue Unknown introduced earlier, that anything can be written as m plus 1 into m minus t. Most of the numbers are
not visible, sir.
Screen is, you're also not visible. So I think the problem is on the other end. Yeah, now it's visible. Is it visible now? I think it should be. Everyone else?
Sir.
No, it's not visible.
Hello.
Hello. Yeah, Vivek, I can hear you. Sadly. Okay. Anyways, one second. I'll just try to switch to a different connection. Can you guys hear me? Is it better? Is there a lag? Is the screen visible now? We can see PPT. That's what I want you to see. Oh my God. Okay. What did you expect? Movie, Netflix? Okay. Anyways.
Sir, can't see even PPT.
What?
Now the PPT is visible.
Now it's visible, sir.
That is a YouTube screenshot on the PPT. I'm not on YouTube. Okay. Oh my God. Okay. Anyways, with that being said, let's continue on. So 3 Blue Unknown does this. It's amazing. But I'll just go over what he's trying to do. Okay. So if you plot any x square, do you agree any quadratic equation represents a parabola? Do you agree with me on that? I don't know. Hope you agree on that or not. You can try it on Desmos if you don't agree. Okay, basically open Desmos. Okay, and then type, I don't know, any quadratic of your call. X minus 1 into x minus 3 into x minus 2. What does it give us? A parabola, right? You know this. Yeah, fine. Is this fine? It cuts at exact 2. We did this, right? Come on, tell me. We did this. Yeah, thank you. Good. So we did this. The question is, when does this become 0? And when you ask that question, of course, it becomes 0 at 2 and 3. The points 2 and 3. But you'll observe something interesting. Do you see that there is a midpoint between the roots? There is a midpoint exactly between the roots. So 2 and 3, if the roots are, then there is a point exactly in between called 2.5. Hope you can see that. It exists if I do 5 also, like 4 is the midpoint, if the roots are this thing. The minima, you would say minima. It need not be the minima always. Depends. If I play a game, it could be the maxima. Okay. So you guys can see that. This will come into being later. Okay. Come into use later. Yeah, it's an extrema. Yeah. Anyways, with that being said, so there is a midpoint. And then do you see how much is the distance between the roots? What is the distance from the midpoint to the roots? Tell me. How far are the midpoint roots? Why is it shape called parabola? I have no idea. I don't know why. Seriously, just called it that. Okay. Anyways, what is the distance? 1. Do you agree it's 1? The distance from 4 to this thing 3. From the midpoint, that 4, the distance is 1. Do you agree? Do you agree the roots are 4 plus 1 and 4 minus 1? That much I want to know. Do you agree the roots for this equation are 4 plus 1 and 4 minus 1? That's what I want to know. That's important. This idea is very important. I'm asking why it should give shape. Why it should be a shape like parabola. Okay, I think I've explained this before. I don't want to explain it again, but still, what is the equation y is equal to mx plus c give? Come on, tell me. What does it give us? Y is equal to mx plus c. A line, right? Yeah. Now, I have a question for you guys. What if I change the slope with x? Like, what is the slope of the line at 0? Tell me. What is the slope of the line at 0? Tell me what is the slope of the line at 0? M, right? Agree with me, it's 1 now. Agree it's 1 now. The slope is 1. What if I change the slope continuous? Like at 1, the slope will be 1. At 0, the slope will be 0. At 2, the slope is how much? 2. If I do that, what will happen? I'll change m to x. Do you agree with me? What do you think is going to happen? Do you agree it's a parabola? The slope is continuously changing now. What is basically, instead of m, I put x there. The slope is changing now with x. That gives you x square. Yeah, you got the logic though, right? No, one second. Okay, if you didn't get that, listen. So you have the equation y is equal to mx plus c. That's the line. The slope of the graph is 1 everywhere. The slope is 1 everywhere in this line. But what if I change that slope depending on the x? What if I kept changing that slope continuously? Yeah. So what if I kept changing the slope? Instead of when it reaches 1, I change this, I make it more steeper. When I go to 2, I make it even more steeper. So what I do is I vary the m with x like this. In place of m, I'm going to put x. So what will happen now? Do you see the slope keeps changing continuously? Yeah. So my point is, my point here is very simple. That's how you get a parabola for x square. X square plus c is a parabola. Okay. So you can interpret most of the things like this. Okay. I can go over some crazy examples, but this is the only one I could think of easily. But yeah, there are other crazy ones you can think of. What if you make it vary with y? Try that. You get some complicated things. What if m was the distance of the point from the origin? Oh, you could try. You could do it as, you'll get some complicated things. X square plus y square. Yeah, that doesn't look good to me. That looks really weird. Could be I don't know, some sort of creep. What is that? What is this called? Creepers? The ones that go around the trees. Vines, whatever. Okay, same thing. Yeah. Oh my God. Biology. Climbers. Okay, thank you. Okay. Don't tell Vinit, sir. Okay. Anyways, going ahead. Yeah. So you can go on like this. Like, for example, you can go on like y is equal to sine x. What does y is equal to sine x do? Tell me. Y is equal to sine x. What does it give us? It's a sine wave, right? It's a wave, right? Yeah. But if I multiply it by 2, amplitude grows. Agree with me on this? The amplitude grows. Now, what if I change it to some x, where the amplitude goes on increasing depending on the x? Butterfly, welcome. Okay. You could have divided by x and shrunk this thing also. That's also possible. Here, what happens is this thing shrinks. The amplitude shrinks. Got the logic? The amplitude goes on shrinking with x. Yeah, you can try some crazy things. Up to you guys. Cool. Figure it out. But this was the answer to Murali's question. Why he asked why it gives a parabola, why x square gives a parabola. That's what I want to tell. The roots line calculus, but why? Okay, the differentiation part and stuff like that. The reason why. Ain't a butterfly, it's a tunnel. Oh my God, you 3D animators. Okay, look at it from that perspective itself. Okay, if you make x is equal to infinity, then I'm crazy. Desmos will be like, I can't do it. He'll just show a middle finger to me. Okay, anyways, wait a second. Teachers these days have such limited imagination. That's Murali obviously telling. Okay, anyways, if you want to see the heartbeat, you have to plot 1 by sine x, it seems. Yeah, it could work. 1 by x into sine, yeah. Could be probably like that. So yeah, by the way, your voice doesn't look like this. If you ever speak into a microphone, you know what your voice looks like, right? Have you seen your voice, by the way, this thing waveform in this thing? It's horrible. Yeah. Yeah. You can use Audacity, whatever you want. Listen to your, just once record your voice and see this thing. Okay, waveforms of it. It's much more complicated. It contains not just sine x, what not stupid things are there in it. Okay, it's going to be very ugly. But anyways, I won't get into that. That's something with the other class. I don't want to discuss that now. But I hope you guys agree it's a parabola. Do you agree there's a midpoint and then the roots are separated by some distance always? Yeah. If you agree on that, I hope you agree with this. Listen to this carefully. This is what 3Blue11 does. I'll call the roots as R and S. Okay, I'll take the roots as R and S. Okay, I'll do that class sometime. Okay, when I teach sound chapter, I used to do those things like Fourier transforms and all that stuff. Anyways, so there's a midpoint. There's always a midpoint, and that midpoint is at the exact distance. Okay, at a distance d. The roots are at exact distance d. Got this logic? So, for example, in our earlier example where we took the quadratic, the roots were at 2 and 3. The roots were 2 and let's say 4, or 2 and 5, or 2 and 6, let's say. Then the midpoint was 4. And the distance between the roots was 2. Agree with me on this? Got this logic? The distance between the roots, distance from the midpoint to the roots was 2. Now, basically what I'm saying is, if the roots of the parabola are 2 and 6, do you agree there's always a midpoint? An axis which cuts the parabola exactly at 4, halfway through. Yeah. What is this given by? How is this 4 given by? Tell me, how do you get this 4? If I give you 2 and 6, how do you get 4? Basically, I'm asking that. It's 2 plus 6 divided by 2. Agree with me on this? It's midpoint formula. It's midpoint formula, right? Yes, midpoint formula. So it's going to be 2 plus 6 divided by 2. So it's going to give you 4, or R plus S divided by 2. Hope you agree with me on that. Yeah. If you find out that directly, somehow the midpoint, remember, if I were to give you the midpoint and if I give you the D, do you agree it's very easy to solve the problem directly without thinking much? If I give you the midpoint and the distance done, the problem is done. Okay. So if you look at the equation, what are the roots of this? Tell me, what are the roots of this equation? This is a parabola, right? What's the roots of it? Come on, tell me. What are the roots of it? R and S, right? It goes to 0 at R, x is equal to R, and it goes to 0 at x is equal to S. Hope you agree with me on that. Yeah, those are the roots of it. Okay. But if I multiply it out, do you agree I'll get this? I just multiply it out, that's all. Multiplying out and simplifying, you get this thing. Is everybody fine with this? Just asking. Because the idea is that its core is this. So this is what 3Blue11 explains in that lecture. Okay, basically. Okay. But if somebody out there in the world gives you this quadratic equation, this one, do you agree you can immediately identify B as R minus R plus S? You guys know that. I know you guys know that. The sum of this thing is given by something B, something related to B. You guys know that, right? The sum of the roots is given by something related to B. But then C is the product. C dash is the product. Agree with me on this? Yeah. So now this leads to R plus S by 2 is minus B dash by 2. Agree with me on this? Yes. But what is R plus S by 2? Midpoint. Agree with me on this? No, I just brought up and said, if somebody gives you an equation of this form, if somebody gives you someday an equation of this form, someday in your life, Somebody comes along and says, okay, look, there's a quadratic equation like this. I've run into some problems. I don't know how to solve. Somebody gives you like that, let's say. Okay, let's say Keaton comes to you and asks, I don't know how to solve a quadratic equation. Okay, anyways, he would never do that. Okay, it's impossible for that to happen. Yeah. Anyways, when A is okay, Keaton says it's when A is 1. Yeah. How to find D? Wait. We are not in there. But now the question is, you can find M. Do you see you can find M just looking at the equation? Do you see you can find the midpoint? Just by looking at the equation, you can find the midpoint. Yeah. Then, I don't know whether you agree with me on this. C can be written as M plus D into M minus D. Agree with me on this? Yeah. Which simplifies to ultimately M square minus D square. Yeah. Which eventually leads to D square is equal to M square minus C dash. I just plugged in whatever knowledge I had. Okay, I just plugged in the value for R and S. What is R and S? M plus D and M minus D. Okay, I just plugged it there. That's all. Nothing much. Okay, I know it's going to get interesting. You'll know what I did. Okay. Now, the question is, can we solve quadratic equations like this? Yeah, I know, Murali. 1 second. Why is B by 2M? Because I told you, right, R plus S by 2 is midpoint. I told you that each root R and S can be given as M plus D, M minus D. R is M minus D. S is R plus D, M plus D. Midpoint plus distance. Yeah. 1 second, we're not done. If I give you something like this, what is the roots of this? Tell me, what are the roots of this? Come on, tell me, quickly, solve this. What is the fastest you can solve this? Yeah, some of you know the other methods, and yeah, that works. Shashank, you're right. Varun, you're right. Nihad, you're right. Yeah, Sathik, you're right. But do you agree it's of this form? And then I've told you that for some reason I have given the formula for midpoint. What's the formula for midpoint? Minus B by 2, right? Agree with me on this? 1 second. Is this fine? Midpoint formula is minus B dash by 2. Yeah. So that directly gives us, what is B dash here? What is M then? Tell me, look from the formula, what is M? From this, based on what is midpoint. Hope you agree it's 2, right? Immediately. Yeah. Now, if you plug in that M here and minus it from C square, what is C dash? 3, right? If you subtract it, what do you get? Tell me. What is D square? Yeah, that leads to 1. So what are the roots? 2 plus 1, 2 minus 1. All I had to do was a simple calculation without thinking of anything, quadratic formula or anything. I just found the midpoint. I just found the distance.
Was that supposed to be amazing?
Yeah, it's supposed to be amazing because of the speed at which you can do this. Okay, just by looking at it. I know, not genius claps, it's slow claps. What is P? I'll come to that. I'm calling it product later. Okay, I'll just call it product.
Can you even read properly?
Yeah, I can.
I said genuine, not genius.
Oh, genuine. Okay. Sorry, I didn't see that. Okay.
What more can you expect from teachers these days?
Yeah. Says the guy who misreads time and frequency, time period and frequency. Okay. Yeah. Anyways, doesn't know the difference between them. Okay. Anyways, solve this. Come on. What's the solution for this? Let's see whether you solve it faster than me. For me, click, solution, done. I can always solve faster than you. Okay. What's the solution? Varun competing against Prajwal sir and PowerPoint and giving the answer as correct. Yeah, that's correct. Yeah, Sakshi, that's correct. Now, according to my method, all you got to do is take minus B by 2. So 8 by 2, how much is the distance? How much is midpoint? Tell me quickly. Midpoint is? Okay. Shashank is bragging. I have Wolfram Alpha noobs, it seems. Yeah, I know. Okay, that's always there. But Wolfram Alpha sends it to the server and takes some time, dude, to solve. Okay, but do you agree the midpoint is 4 immediately? Once you get the midpoint, what's the distance? M square, you got to substitute, 4 square, minus 12. Take the square root, 4, done. So the roots are 4 plus 2 and 4 minus 2. The point I'm trying to make is not about the computation, none of this. My very simple point here is, so far, whatever you're doing in your life, that M plus D and M minus D, Okay, whatever that was, ultimately was this midpoint and distance formula at work without your knowledge. Okay, whatever you were doing. I'm not saying ask you to ignore the negative root. I'm not even asking you. Here you don't need to, we're calculating distance here. This not be plus or minus 4. We are calculating plus or minus 2. You can take it as plus or minus 2 and then do it. But we understand it, right? Why to subtract? That's the distance between the roots. Okay. Wait, you'll see. Try the same method for a problem which has complex roots. You will get something interesting. Okay. Try. Take a complex equation such as x square plus x plus 1. Try that is equal to 0. You'll get something interesting. Okay. Now, what about this case? Tell me. What is the roots? So if you're good at this, Varun being genius, figured it out quickly. Yes. Satvik also figured it out. Sakshi figured it out. Ketan figured it out. Anita figured it out. And Shashank is typing a tool from Alpha right now. Okay. Anyways, just kidding. Okay. You can solve it. I know. You look at it and solve it, but still. Why, dude? Why? Okay. Anyways, yeah. Most of you are correct. But my point is, if you use this new method which you have studied, m is minus 1. Agree with me instantaneously. Midpoint. You look at the equation and you can tell the midpoint is minus 1. It's faster. It's just faster a little bit. Okay. Then you just need to plug it into the formula m square minus c square. Ta-da! D is equal to 4. D square is 4. So D is 2. So the roots are minus 1 plus 2, minus 1 minus 2, giving it minus 3 and 1. Is this method faster or is this slower? What do you think? The graph is obviously wrong. The graph is a toy graph here. Okay, I'm sorry. Okay, graph is wrong. Is this faster or is it? Okay, what is that? 0 plus or minus root of. Wait, did I use?
Hello. Is he dead?
Sir is not speaking.
Quite possibly dead. Unconscious. Brain cheeser.
Why am I getting cricket sound?
Sadly, you are alive.
Yeah, I know. The cricket sound, I know. But anyways, that's not the only problem. The only problem, other problem is, yeah, that was. Who was the host in the thing? Don't tell me it was. Okay, let's continue on. Ta-da. I became it seems. Okay. Keaton says I would write graph is not to scale. Fine. Done. Okay, with that being said,
Demoted to Picasso skill level 0.
Yeah, I know. I don't mind the demotion at this point. Anyways, saves fuel, but efficiency is unknown.
Sir, again a spelling error. Not for scale, not to scale.
Graph is not to scale, right? Is it not for scale or not to scale? I'm confused. Not to scale, right?
Not to scale.
Yeah. Not to scale. It is fine. It is fine. Not to scale. Hey, what you should be complaining is about the diagram, the beauty of the diagram. Oh my God. Okay. That should be the concern.
There is no beauty in the diagram.
I know. You need to see it. You need to graduate to a certain level to see it. You know, it's like, this is.
Yeah, like to 0 plus minus 1 I.
It's abstract art. Okay. If you can't appreciate this, I'm sorry. Okay. There is structure in it. Okay.
Yeah, we have to appreciate it at least better than your
I bet
face.
this painting gets sold for some, I think $400 or something Any West?
Beauty lies in the eyes of the beholder.
Wow. Okay, fine. Thank you. Anyways, with that being said, we'll cut it off. Anyways, some of you did not get the method probably, but the idea is simply look at M value. Simply look at the M value. If I calculate the midpoint using this formula, look at B and just do divide by 2 and minus 1. And then immediately plug it here, M square minus C square. That is the next number 3. Just works. It's definitely slower. What's slowing you down? It does not work for imagined numbers. It does work. It does work. The method should work. It should work for imagined numbers too. D is the distance. D is the distance from the midpoint. How far it is. Oh, that cricket sound is coming from Vivek's mic. It seems. Okay, fine. Where do you live, Vivek? What does M is equal to minus 1 suggest? M is at minus 1. It just means negative slope. That's all. Okay, done. I didn't get that. Okay, anyways, with that being said, listen to this. I hope you guys got the method. Is this fine? Is the method fine? Did you guys get the method? You find the midpoint and then you find the distance to the roots and then calculate the roots. The formulas are 2 formulas. That's it. You just need to know 2 formulas in your life. You're done. Is this fine? You can just look at the equation and tell these things. Okay. Now, why this method is better? This was a method used by Babylonians. Okay, the first. Okay, and 3 Blue 1 says this is a good method because I'll tell you why. I'll tell you why. D becomes imaginary. Yeah, that's why distance becomes imaginary. That's fine. Wait. Now, if you look at this, do you agree that D square is M square minus P instead of C? It's minus P, product of the numbers, whatever is the product here, C coefficient. Yeah. But D is square root of M square minus P square. Okay. And in the end, 3 Blue 1 gives this formula because, roots are M plus D and M minus D. So you get this thing. X is equal to M plus or minus square root of M square minus P. Isn't this a cute formula compared
Why
to that?
did the Babylonians have to solve quadratic equations?
I have no idea. For joy, Murali, for joy. The same reason why you spent 7 hours doing physics. Okay. For joy.
Okay, at least you agreed it is physics and not organic chemistry.
Oh, that was a slip of tongue. I'm sorry. I'm sorry. That was a slip of tongue. No offense.
At least it did not slip out of your mouth.
The Babylonians need to get a life, it seems. I don't know. And by that logic, even Indians should have gotten life. They got Pythagoras theorem for no reason. Okay. Yeah. Anyways, I hope, no offense to Babylonians, and I don't have to care. They're already dead. So anyways, with that being said, X is equal to M plus square root of minus. Does this look better than the minus B square minus 4AC formula? At least, like, little bit good looking. Come on. Don't hurt.
Are you attracted to equations and formulae? No, really,
Possible.
you care about whether they're good looking or not.
Care about it. Like, for example, everybody loves E equals MC square. Why do you think? It's simple, cute. Come on. It's a small formula. Anybody can remember this. Nobody likes the lengthy Lagrangian, which is the particle model. Nobody has seen it. They say you require 3 T-shirts to write that equation. The one that describes the theory of everything. Current biggest physics theory which we have, which is better than Einstein's relativity and everything combined, uses an equation which can fit 3 T-shirts. Okay, so it's beautiful. This is beautiful that way. Okay, so anyways, that's 3 Blue 1 Brown gives that formula, but it's no different from what you've learned. If somebody gives you this equation, ax square plus bx plus c is equal to 0. Yeah. You know that you can divide by this thing and a and get that. So immediately you realize r plus s, sum of the roots is minus b by a and product of the roots is c by a. Agree with me on that? Now, if you use my current methods of solving the problems, midpoint is this. Okay, this is the midpoint. The product is c by a, which I've studied. Yeah. Now, if you use the formula which is given by 3 Blue 1 Brown and plug it back, do you agree you'll get this? Hope you agree with that. Just plugging in, that's all. Just plugging in m, plugging in m square and then p. Yeah. Simplify it. Do you see something familiar? The same boring quadratic formula. But my point is now, do you see what is happening throughout? This was the midpoint. This was the distance. Okay, the whole time you were calculating distance. That's why it had that square root of Pythagoras field. B square minus 4ac as the Pythagoras field. Okay, you know, all my chem doubts clear. Yeah. Amit's, yeah, fine. 1 second, Shashank. Nobody in this is just going to start asking this in the middle of the conversation if they don't want. Oh yeah, that's going to happen, of course. Yeah. Anyways, I know it doesn't sound very fascinating to some of you, but the idea is that that's the gist of it. That's where 3 blue unknown is getting at. And this has more advantage of understanding this rather than just getting this boring formula. It's just boring. If they give you that, it's really boring. Yeah. Anyways, continuing on, I want to show you something now. How to solve cubic equations and advanced equations. Now, there is a very fascinating way of solving it using turtles, papa turtles. Okay. I don't know how many of you have seen this before. This is a method that was taught back in 18th century. They stopped this method for some reason. We don't know still. Why did they stop it? This is a very old method, not the Cardan's method. Okay. It doesn't involve turtles, to be honest. Okay. It is a reference for Python, the turtle, this thing in Python. Okay. The code. There's something called turtle in Python. You need to check it out. I'll just open the video for you. I'll show you. This is crazy. This video is awesome. It's from Mathlogger. It's very famous. It's a very old method. Solving equations using turtles. Okay. You can solve even cubic or anything. Okay. Listen to this. Can you see the video? Some of you watched it. Okay. Kind of watched it. It's amazing that it works. Okay. Can you guys see the video? Can you see the video? Okay. Observe this. This is premium content. Look at this.
Welcome to another Mathologer video. Let me show you something really amazing. How to solve an equation by playing laser tag with a turtle. That sounds very strange, but just wait and see. Okay, here's an equation. Here's our...
It looks complicated, right? Very advanced and complicated. Yeah, it might go above your head.
A turtle, and here's my laser tag gun. Here's the turtle at its starting point facing to the right.
The turtle faces to the right first, okay?
The leading coefficient of our polynomial is 1. This tells the turtle to walk 1 unit to the right. Now he makes a quarter turn in the counterclockwise direction. He's now ready to go up. The second coefficient is 5, which tells the turtle to advance 5 units. Yes, I know it's a very speedy turtle. Probably doesn't like the look of that laser. Anyway, another quarter turn counterclockwise. The next coefficient is 7. Advance 7. One last turn. The last coefficient is 3. And the turtle finishes his trip by advancing another 3 units. Now we place our laser at the starting point and aim to tag the turtle. But of course, a straight shot wouldn't be very sporting. So like billiard players of old, we'll try to zap the turtle with a bank shot like this.
That's a demo.
But our bouncing rules are special. We have a weird laser that always bounces off making a right angle, like this.
Okay, usually in lasers, do you agree the angle has to be exactly equal? The angle of incidence is equal to the angle of reflection. But here that's not the case. It gives a 90-degree angle. Okay, it gives a 90-degree like this. Okay, and you need to shoot the turtle. That's all. Now observe this.
Missed, but by angling our laser shot slightly differently, we can arrange a hit. There. Great fun, except maybe for the turtle. But what's the point? Well, believe it or not, we've also found a solution to our polynomial equation. It turns out that to make the killer shot, our laser beam began with a slope exactly equal to 1.
That line is 1 roughly. For rise is 1. This thing, what do you say? Run is 1. So it's roughly 1. Okay. Now, if you observe, if you don't believe me, just plug in 1 there. It works. That's the solution.
And for the game we are playing here, it turns out this promises us that -1 is a solution for our equation. Don't believe me?
Sorry. -1.
Let's check. Let's see. All right. 5 plus 3, that's 8, -1, -7, that's 0. Okay, let's allow the turtle back into the game. That's a cubic equation down there, so hopefully we can find another solution. And it turns out we can. tilt the laser a little more. Okay, keep going. There, a second hit. Here the initial slope is 3, which means that -3 is a second solution. And yes, there's also a third solution, but we'll worry about that later, okay? Surprised? I sure hope so. I definitely was. And with suitable adjustments, our turtle laser method works for any polynomial equation.
It works for any polynomial equation. You can try this for however complicated your this thing. We just need a geometry construction though to solve it. But you need to do coordinate geometry probably. But the crazy part is the method works. The method works. It was taught in the 18th century for solving a higher order polynomial. But the reason why it works is more awesome, which he spends about next 20 minutes of this video explaining. Okay, I'm just going to give an introduction. You guys are going to, you can check it on your own. Okay, it's going to take a lot of time. Yeah, you don't have to hurt this thing. What do you say? This thing, turtles. Anyway, no offense to turtles. Okay, yeah, we'll go for a break and then we'll be back. Is that fine? 5-minute break. Go, 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 go. Smash some water to your faces. Or anything you can find. And Murali's case, probably a conical flask. Okay, why only turtle? Why not Rajul? I have no idea. Your call. You shoot anything you want. I don't care. If you're interested, there is a animation done. It's called Lil's method. The method is called Lil's method. If you're interested in knowing what is it. Oh my God, this is BSNL. Stupid. Giving me ads. Yeah, so you can see it here. You can solve it. Somebody has done it for cubic equations. You can solve any cubic equation with any coefficients. The thing gets complicated with the, I don't know, 9 or let's say -1, stuff like that. You can try it out, but it gives you the roots. It gives you the roots. Surprising. There are some complications which he discussed in the video to check it out, but it works for most of the things. Then why can't we derive solutions to general polynomials like this? You can try proving it using the same method. You'll fail. You can try using Lil's method to derive for the quartic equation, just like he does it in the video for cubic. It won't work. It won't work. You can try it out. The reason is very advanced. You have to study group theory, and I know only one book which can explain you why there is no solution without getting very complicated, and that's Visual Group Theory by Nathan Carter. It's one of my favorite books ever. Least equations possible. Visual Group Theory. It is the only one which speaks about Galois theory. By Nathan Carter. Nathan Carter. Visual Group Theory. You guys have to check it out. It's amazing. Field extensions and whatnot. It goes very advanced. In the speed quiz, we get speed negative, but speed isn't negative. There were many roots. You guys messed up. There are 2 roots to the solution. I don't think you'll get negative. One more thing. As far as I know from the quiz, you won't get negative. But even if there was a root, if you're solving it directly, the hyperbola, you'll get something negative. But if you're doing it with this thing itself, with caution, you won't get a negative. With simultaneous equations, it's less chance you'll get a negative. Everybody got negative. That's interesting. The board question, okay. How is that possible? Which board question are we talking about? The board goes upstream, board goes downstream. That problem. Oh, let me check. I'll not share the screen with you guys because you can see other scores. Just check it out 1 second. Meanwhile, you can stare at this beautiful formula. While I'm at it, I'll just see the solutions. 1 second. I'll just, previous quiz, the scores are out. I have sent the scores to you. Wait, your scores are released. The classroom quiz scores. No? Oh, let's see. Let's verify. Maybe I'm wrong. Okay. I'm sorry. We'll do that now. Give me a moment. I shall release the scores now. You should remind me. Sometimes I forget what this course. It is called System of Equations. It was assigned at 8 o'clock. Import grades. Oh yeah, it's not released. Okay, I'll release this course, but if there is any issue, I'll change the answers later. Is that fine? Your current scores will be released to you. Is there a quiz today? Depends on how much I complete. If I complete something, there'll be a quiz. If I don't finish a particular part, there won't be a quiz. The scores are not released just after finishing the quiz. The reason is there's a security issue. The problem is I want to review them before sending the scores. If you guys complain that there's an issue with some of the answers or something, it's better. It'll create a mess on Google Forms. It's very messy. So yeah. Any fun problems? Yeah, coming up. I have a Putnam level problem in this chapter. I've kept just like that, one question, nothing more, just like that. This if you're interested only. Towards the end. Hey, Putnam is easy. It's not really hard. There are different levels in Putnam, but one of them, Putnam is the hardest exam in the world, math exam in the world. Okay, look, whatever answer you got, can you plug it back into the equation and check? Whatever -3 or whatever you got, can you plug it back? Not -3, plug in 3. No, is -3 possible for speed? That's the first question I need to ask. I'll rewrite it, I'll solve it if possible. 1 second, I'm just looking through it now. I remember solving this. You are wrong. Wait, let's see. I don't know. I could be. Yeah, that's the old 3 Blue and 1 episode, but yeah. Putnam was a place. I think so it is. Yeah, fine. I might be wrong. Let's see. 1 second. What is the problem I gave though? I've forgotten. What is daughter's age? Oh, not this one. Next one. You had a kid at 15 years of age. Sadly, yeah, probably. 1 second. Child marriage issues. Let's cry over it someday. I'll cry over it someday. The boat goes 9 kilometers upstream and 12 2 hours it can go 6 kilometers upstream and 4 kilometers downstream. Sounds like a question I would create. Okay. Anyways, what was your answers, guys? And I'll solve it. Solve it using Desmos. 1, because 9, 12, 6, 4. Okay, got it. 9, 12, 6, 4. 9, 12, 6, 4. 9, 12, 6, 4. One second. 9, 12, 6, 4. 6, 4, 2. Okay, so one of the solutions I see here is 6,3. One of the solutions I see is 6,3 here. Wait, somebody says, the answer is 6, minus C, but speed it can't be negative. What? Oh, wait, let's see. This is not possible. 4 kilometers downstream. Oh.
How can a boat go faster upstream than it is downstream?
Yeah.
Stupidity of Raj will reign supreme.
Wait. 6 kilometers upstream, 4 kilometers. Okay, grace marks everybody. There is no way you can solve this. Okay. Yeah, you get negative speed, but you can make it positive. The answer was 6,3. If you make it positive, the answer works out. Like Sakshi got it right, but I get it anyways. You'll be getting a Grace marks of 6 marks. What is that quiz even for then? Like,
You should be more careful while copying questions.
I didn't copy, I cooked up that values. That's the problem. If I had copied, at least it would have been better, I guess. I didn't see that. I was like happy looking at Desmos. Oh, it works. Awesome. Hey, wait. There's an issue. 6 in 2 hours. Wait, I think I can sort this out. Downstream is x plus y. 6 kilometers, x minus y. 9 and 12 in 5 hours. No, I'm right. There's a solution. Guys, try out the values. I'll give the values what to try. Wait. No, there's no solution. Okay, sorry. Sad. Thought there could be a way to resolve this. Damn it. It was my mistake. I put a negative.
Everyone look at Muralidhar.
Fine. We'll frame that and put it in the safe classes someday. Free marks, yeah. 3 plus 3, that's 6
Not
marks.
for everyone. I'm doing this only for PD. So that he needs his webcam.
Why would I do that? Dude, not
Because
even,
it's stupid.
that's worse than being a cannibal. Webcam, seriously. I don't know. 1 second. Sadly, there's nothing on my table that is eatable. Other than probably some ants which are going somewhere. I don't know. That's all. Papa, let's...
Don't start man versus wild here.
Okay, fine. Yeah, I know Satvika. We can say Jai Satvika because she raised the doubt about that question. 6 marks. And heater. Yeah. Okay, guys, come back. Come back. Okay.
Looks like at least somebody cares about your dumb quizzes.
Yeah, thank you. Sadly. Yeah, Grace marks, guys. Grace marks. Anyways.
Sir, I actually texted you that night itself.
Oh yeah. Was it on Schoology?
Yes, sir.
Then that's the problem. I didn't check Schoology. Leave emails. I have not checked.
What do you check anyway?
Yeah.
What do you even check?
You can expect a reply next year.
Yeah. That's only for Murali. Should I screenshot that? The reply of yours? The time we spent 1 hour solving a physics problem. You know that? Good memory. The best memory of your life. Okay. Anyways, I'll be closing the webcam because if I start the presentation, it's going to lead to a lag. Okay. 1 second. Yeah, I'll do that. Shashank, 1 second. Shashank requested something. We'll give it a shot. The mics are off now. Okay, wait. Why do you have ants on your computer or your table? I said there's one ant, lonely ant, which is going. And Murali made me desperate to eat it. What did you miss? The eating scenes? Yeah. No, I just commented saying there's nothing eatable on this table. Okay, right now. Sadly, there was one ant, lonely ant. Okay, good. Fine. Dumb face, it says. Did you still debate? No, I'll delete the quiz later. That'll be sorted out soon. Regarding the coding sessions, whoever is coming in, I'll be posting a video. Okay. So I'll be posting 2 videos, YouTube videos on how to install Python on 2 systems, like whether it's Mac or this thing. So please follow those instructions and come for the classes tomorrow. Okay. I won't be writing down the instructions, but this is too much work. It's pointless also writing it down. It's, to be honest, it's pointless because the problem is the instructions for Mac are different. Instructions for Windows 7 are different. Instructions for 2.7 are different, Python 2.7. There are so many complications. So with Python. So the only solution I can think of is that, and I'll explain the steps though. What's happening during the installation, I explain that tomorrow. But I need Python for tomorrow badly. I'll look into your what you say. I'm running into the mics. Okay. Have you seen the coding submission? Yeah, look into the coding submission soon. I have checked some of them, and it's amazing. I felt like living more years on this planet after seeing them. Yeah, some of you have self-roasted yourselves. That was a rarity, but majority of you roasted me. Anyways, I saw that coming. Yeah, that was part of the deal. Yeah, wait. We'll see that in the class tomorrow itself. Okay, whatever you guys did, stupid things. Yeah. Anyways. What is done first class? We just created a bunch of memes. What is done first class of coding? Ask them. We just made memes. They roasted me. That's all. Yeah.
Sir, how to copy the image if it's in desktop to Google?
Then you have to use desktop path address. my computer / that stuff. You need to get the URL. That's all. Important.
So
Does it have to be a meme? No, it did not be. Yeah. Yeah.
Can you repeat it, sir?
Basically, you need the file's path, like what is the address of the file, the image file. So if it's on a desktop,
I tried copying the image file, but it's not coming, sir.
Then I don't know. It's possible sometimes things can go wrong, but yeah, we'll look into it. Should I eat 3 sandwiches or 4? Guys, Murali wants to vote it since he needs to eat sandwiches. Murali, nobody cares. You know that, right? Yeah.
Then why did you ask for the vote in the first place?
No, I just wanted to see if they'll even respond. Bother responding.
Did you know that information travels at the speed of light? You can't get responses instantaneously.
I got I'm still getting the responses. Okay, wait. One solution is hope is no one cares. One response was yeah. Wait. One response was 4. Somebody cares about you, Murali. Somebody cares about you. You need 4, it seems. Yeah. Somebody cares about you too much. 200, it seems. Yeah. Anyways, we'll continue. I think everybody's back. So yeah, we can go ahead. So going ahead, one is that was happening, and we decided that discuss this. Yeah, I gave you this earlier. If I give you, you know the formula now, right? Which one is the answer for this? If a polygon at regular sides, what is the number of these things? Still doesn't matter. I get to change the truth, Murali. Sorry, Shashank. Murali is back. Okay, which of them is correct? Obviously. See, if you were answering a problem in NCRT and if it was an MCQ, this is an easy quiz. You can just play around with special cases, right? You know what happens if n is 3, right? For a triangle, how many sides? Tell me. 0 diagonals. Yeah. Which of them gives you 0? Only this and this. All of them are wrong. You can rule out. And then ultimately you can even rule out plug in 4. It gives you fractional. Nothing should be fractional, right? Hope you agree with me on this. Shouldn't give you fractions at any cost. That's possible if only if the top part is an even number. And the only way you can make an even number is by multiplying an odd number with an even number. Okay, odd number with odd or odd number with even number ultimately. So that's the point here. That's the gist of it. Yeah. This is not brilliant.org. This is looks like that, right? Yeah. Anyways. Now the question is, fun fact is, there's this interesting thing about intersecting diagonals in polygons. That's really fun. The diagonals intersections form some figures. They're very famous. Okay, some interesting things are formed. Few years ago, there was this one of my another favorite problems out there, given by 3Blue1Brown. There's a video on this. It's about how many faces, how many regions do these diagonals cut it into. The question is, if you have an n-sided polygon, how many regions, kshetras? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The question is that. Got the logic, right? That is an even harder problem. You can check it out. It's fun solving this. It's much fun solving this. It's on this YouTube video called Circle Division Problem. He gives a solution for it. Back in the day when he was very much, beginning his YouTube channel, he was posting more of this type, where he was doing a follow-up of the video and doing this kind of stuff. Simply calculate the number of intersections. How will you calculate the number of intersections? That is the challenge. That's a fun part of the video. Okay, do check it out. And then he uses a formula which I know by the name of Nai Raja Agittu. N plus Raja R Agit plus 2. Yeah, this was the way we learned that formula for some reason, because our math teacher thought that thing. So nodes plus regions is equal to edges plus 2 for any graph. Okay, so nothing to do with the Nai, nothing to do with anything, but it's an interesting graph theory result. It's called Euler's formula. There are too many Euler guys, Euler formulas, because the guy is everywhere. But you can check it out. Yeah. Thank you, Shashank. Anyways, now tell me this one quickly. You guys know this, right? Do it. Tell me the answer for this quickly. Use the formula like first standard kids and tell me the answer. It's easy, right? 35 diagonal, how many sides does it have? Oh, no. 35 diagonals, how many sides does it have? Ulta. I'm asking you how many diagonals it is. Yeah, Varun, that's correct. Shashank, that's correct. Sathik, that's correct. Ethan, that's correct. Yeah, I've given you the diagonals this time. I'm asking you the sides. How will you do this? This is a commonly asked problem. How many of you seen this before? It's a famous problem. Listen, I'm not giving you this thing. I've given you the diagonals this time and asking you for the number of sides it has. Now, yeah, that's correct. Yes. Nope. Others are wrong. Okay. Yeah. Chocos, seriously? Okay. Fine. Yeah, Niha, that's right. Mithul, that's right. Thank you for sending multiple messages simultaneously. No, can't be 35. This is a commonly asked problem. This is a famous one. I just thought I'd do it for you guys. Yeah, Sakshi, that's correct. It's not 23. It's not 35. It's not 34. How can you get, if you have 37-sided polygon, I doubt it will be a 35, this thing, diagonals. It will have crazy diagonals. Some of you are typing numbers from 1, 2, 3, 4, 5, 6, like that. No, that doesn't count. Nah, not 28, not 29. Please like a countdown to my death. Anyways, 7, 6, 5.
I hoped it would have been so soon.
Yeah, I know, right? Yeah. Damn it. Hate to disappoint you, Murali. Nice. Okay, guys, you guys will take a lot of time. It's n into n minus 3 by 2 is 35. So you need to find n. So what does it boil down to? A quadratic. Agree with me on this? Ultimately boils down to a simple quadratic, and you got to solve that quadratic. You guys know how to solve quadratic equations, right? Now you know how many methods so far. How many methods have you taught you in your entire life? How many methods to solve that simple quadratic equation have been taught to you? Factoring method. Then there is cross multiplication. Then there is a formula. Then there is, Naga, that's correct. Then there is, I don't know, the midpoint method today you learned.
Should we also include the useless formula you taught?
Yeah. That also, the midpoint formula, the useless one. Yeah. So including that, I'll do the midpoint method. Okay, if you use the midpoint method, I'll tell you why I'm doing the midpoint method. Once again, Medhan, that's correct, Sanita, that's correct. Why I'm doing the midpoint method is if you use the midpoint, you know midpoint is minus b by a. So it gives you 3 by 2. Minus b, whatever this coefficient is, by 2. Then it's going to be that value squared minus 70. So do you see the method is actually uglier when you start doing it actually? Like if this is a whole number, the formula looks beautiful. Otherwise it's ugly. You get distance as 17 by 2. Okay, the distance between the roots is 17 by 2, which becomes 3 by 2 plus 17 by 2, 3 minus 10 or minus 7. Okay, So yeah, that's it. So this is a 10 is the answer for this 10. You guys know how to solve quadratic, you can use your own methods. Okay. You guys know about completing the squares, right? Come on, you guys know this, right? Yeah, completing the squares. Have you guys seen the visualization of it? What's the method? Have you guys studied the completing the squares method? Okay. Okay, listen to this. Whenever you see the roots as, I don't know, the roots of this quadratic equation can be -3 and -2, it just boils down to this. So you can see, if you look at it carefully, just x plus 3 into x minus 3. Can you go to the previous slides? Yeah, look at it once. Okay, till then, 1 second, I'll go ahead and give a question and come back. Okay, I'll just skip this. This is a question from Patna. Whoever is interested, give it a shot. I'll get back to you guys. This is a Putnam problem. Write it down, screenshot it, whatever you want. A line cuts. Wait. Black screen now. There must be a black screen now. Yeah, you should be able to see the equation now. Yeah. The problem is Zoom is trying to optimize quality over frame rate. You know how much time it takes to send a high definition photograph on WhatsApp, right? 1 MB upload. Yeah, Zoom has to keep doing it every, I don't know, 2 seconds, 3 seconds to keep up if you want to see something every 2 seconds. Nope. Some seconds depending on your speed, yeah, I get it. But to get smooth transition like a video, you need to send at least 15, right? Or at least 30. I mean, at least 5 frames every second at least to make it look like a video at least. I'll come to that. It is just a simplification. You could use -b square minus 4ac. You would have gotten the same thing. Yeah, it could be any line. Your call. But the rule is the line has to intersect. Otherwise, it doesn't work. It has to. The rule is the line has to intersect the graph. The line has to cut the graph. How many of you have heard of Putnam here? Putnam is the hardest exam in the world, math exam in the world. Okay, and this is a problem from that. Okay, this is a problem from that exam. Nidhi, you're thinking. Good. That's smart. But you need to make sure it cuts entirely, but that could work. Yeah, that's fine, Amit. Yeah, it's a UG exam for this thing. Some of you using Desmos. That's fine. I want the solution. I don't care about your answer. I really don't care about your answers, guys. If you plot in Desmos, you'll get some ideas though. But yeah. Yeah, Satvik also, you're thinking the same thing. Nidhi also told me the same thing. That was brilliant, but let's see whether that helps you guys or not. The rule is it has to cut. If it doesn't cut, it doesn't work. Okay. Anyways, I'll go back. I gave you the problem. Check it out, try it out. With that being said, I just want to do a few things. First is the completing squares part. So I think you've done it before. Have you guys done completing the squares here? How many of you have done it? How many of you have not done it? Oh, previous slide. Okay. Just look at it.
Done. It was done in a previous chapter.
So Shilpa ma'am taught us.
Shilpa ma'am taught you guys? Oh God. Okay, fine. Everyone has done it. But have you done it visually? The visual method of it?
What answer if we give you, will you not do it again?
I don't know. I think even if you say anything, I'll do it. The only thing you can do is jump off the roof right now to unsee it. That's the only way. Yeah. Yeah. Okay. So, anyways,
What
I'll
if
be
my
doing
house is in the ground floor?
Or we can make
what
you
if my
fall
house is
from
in the
your
ground floor? Yeah.
or we can make you fall from your uselessness level to your IQ level.
Okay, which is 0, right? The IQ level. Yeah, I get it. Yeah. Okay, once again. That's 6. Forgot. Okay, cool. We'll go ahead. So what we do is completing the squares. You have x squared plus 5. We take this and complete a square of it. Okay. Now the visual method of it, the visual part of it, is you can split this into 2 times 5 by 2 into x. Agree with me on this? Yeah. Okay. With that being said, this can be broken as 5 by 2x into 5 by 2x. Agree with me on this? Split it 2 times, 2 pieces. Fine. Okay, I'll tell you why we are doing this in some time, but this 2 5 by 2x, if you add a 5 by 2 the whole square and minus 5 by 2 the whole square, this whole thing forms x minus 5 by 2. Agree with me? It's 2ab, a square plus 2ab plus b square. Agree with me on this? Yeah, I know. That's the reason why it's given. Did everybody get this? Do you guys, if you've done this, you should remember this. Completing the square. I am introducing you 5 by 2 there just to complete the square. So I get 2ab, 2 times ab. I'm introducing a 2. Okay? Yeah, hopefully that's fine. And that becomes x plus 5 by 2 the whole square minus 5 by 2. Is this fine? Where did 6 go? I've ignored 6. I just thought I'll keep it away for some time. I don't like it. Is this fine? No, it's done for you guys. But as the visual part done, you guys know this part, the visual part of it. It can, the x square can be represented as the x into x thing part, and 5x can be written as 5 into x. Fine with this? Everybody fine with this part? I'm doing a visual this thing of it. So we can choose any lines there and answer. The trick is, yeah, it's called cheating the problem. Yeah, I know that. But yeah, Murali, the key idea is invariance. There's an invariant there which you can't see. That's why I'm asking, what's the invariant? Yeah, I know. Now, do you see this thing? Do you agree with me on this? I've done a split now into 2 squares, 5 by 2 into 5 by 2. Broke it down to 2 pieces. I'll come to what is the invariant later. I really understood, it's fine for now. But the idea is this is 5x, x plus x squared plus 5x, but you can break it into 2 pieces, 5 by 2 into 5 by 2x. Agree with this? I know it doesn't form a square at all, but it will form. Give it some time. Is this fine? Can I get a yes or no on this? Okay. Now next is rearrange it like this. Join the pieces like this. Wherever the x edges are there, join it exactly there. All I've done is I've broken down this 5x, cut it in half exactly, and split it into 2 pieces. 5 by 2, 2 times it was, right? It was 2 times. Yeah. For the problem, the line is arbitrary, but it has to cut. The rule is it has to cut this thing. What is that? The polynomial at 4 points. Okay, everybody fine with this so far? If it's too much, let me know. Yeah, okay. So what we've done is, what I'm trying to say is, this is x squared plus 5x. Agree with me on the first step? Everyone agrees on the first step. Can I get a yes or no? Whoever asked me to explain this. Ketan, yes, the answer is that, but I want the solution. I don't care about the answer. Everybody clear with this step? First step? X squared plus 5x stuff? Does it make sense? Okay. Next part. Do you agree that this can be split into 2 pieces here? 5 by 2 plus 5 by 2. That's what we did. Yeah, you can solve it. But the idea is you can split it into 2 pieces. 2 times that, right? It was 2 times 5x. I just split it into 2 pieces, 2 times this thing. Okay. Next part, I'm joining the 3 pieces like this to form a cute little figure like that. The L shape. But now completing the squares part is you're going to introduce a 5 by 2, a square of side 5 by 2. Do you agree this is 5 by 2 and this is 5 by 2? Both of them. Oh my God, that's terrible drawing. Oh my God, straight lines, straight lines. Yes, there you go. Is that fine? It's 5 by 2 and 5 by 2. There's a square which can be completed over 5 by 2 side and 5 by 2 side, which can be added and removed like to both sides. Okay, so what I'm going to do is I'm going to introduce a 5 by 2 and 5 by 2 to complete the square. But then I have to subtract some piece similar to that. That's the red piece. Now I hope you can see it visually what's happened. Take a screenshot of this and keep. See it later. If you like don't understand something, I think thank you. That is consoling. Yeah. Those Bezier curves. Okay. Anyways, is this fine, guys? This is a visual representation of forming a square, forming this thing. So this is of the side now, x plus 5 by 2 into x plus 5 by 2. Agree with me on this? The side lengths of it are now x plus 5 by 2 and x plus 5. Yeah, that's fine, Shashank. That's totally fine. Anyways, hope this is fine. Just take a screenshot of this. You'll be able to get. You can see that I have converted into x plus 5 by 2, x plus 5 by 2, the whole square. A square of x, side x plus 5 by 2. Okay. Now, completing the square method works like this. Once you get this, you know that you can write this as x 5 by 2 plus minus 5 by 2, the whole square. Okay. If you rearrange this, and try to solve it, you get x. Is this fine? This is just a visual representation of what I did. Everybody fine with the completing squares method? It's just completing the squares. You studied this before, you told me, right? It's just that in place of x square plus 5x, you're writing that. Can I get yes or no? Quickly. Finish it. Yeah. Previous slide, I'll take screenshot. Yeah, previous slide is here, screenshot. If you want it. Print screen is the button for it. Okay. You can try anything. Your call. No calculus needed though. This is quadratic equations. We're dealing with quadratic equations. Okay, anyways. So hope you guys got it that x is equal to minus n, the same. But I want you to observe something interesting. Remember that 3 below 1 formula? Can you see it right there? Again, just saying. It's right there. Hidden in plain sight. Okay. One more awesome thing I learned was you can do this blurring thing in PowerPoint, which I didn't know. It was interesting to learn that you can do that, partial blurring. Anyways, continuing on to focus on things. No, it's just, no, in any version you can do it. At least I think you can do it in the most recent versions. Basically using a soft edge on the circle. Very soft edge. Yeah. Coding assignment is Saturday afternoon, please. Sunday afternoon. Yeah, fine. We'll push from the deadline for the assignment. There's a video by Mind Your Decisions. If you're interested in completing the squares, you can check it out. I'm not showing it because it's too easy. You guys know about Super Mario Quadratics, right? Yeah, you can enroll whenever you want. Yeah. So is this fine? You see, you've done that, right? I've done this, right? You can enroll. Yeah. Remember this Super Mario Quadratics? We played that and I told you to solve the plot in Desmos. Oh, come on. I've introduced this at some point. Okay. That game, Super Mario Quadratics. I can't hear cuss words. I'm sorry. Never. You like Mario? I used to play Mario. You know, I used to get those cassettes. You guys never got to experience that, I guess. I don't know. We used to have those cassettes which we had to put it into that stupid box, DVD player and whatnot. Anyways. But this is the game. Have you guys played this? Please give it a shot next time. Give us a day's time. Oh, by the way, the other batch solved it in 15 minutes, 5 minutes, 10 minutes. That Putnam problem. That's what I'm saying.
So screen is white.
Screen is white.
Now I can see.
That's the console. Yeah, the console was stupid. What we had, it was very cheap, and some games exist on it. I still remember some pointer shooter games that were there. We had to shoot some bird which was flying. That's all we had. There was this thing, Super Mario, on those cassettes. We used to buy those cassettes and put them, whatnot. Anyways, can you guys see the present? Can you guys see the browser?
Yes.
Yeah.
Yes, sir.
This is the game. The thing is, you need to help Super Mario get the coins. That's all. The question is, how should I change the equations so that Big Super Mario can get the coins? Okay. The question is, what are you going to change it to? What is the name of the game? Super Mario Quadratics. Super Mario Quadratics. Yes, Murari, yes. But the question is there a princess? The princess is in the end. Save the princess. The last one. Mario, help me, please. Okay, that's the thing. If you want the princess part, that's there if you want. But world one, there are many words. You need to Princess Peach. I know. It's like a very stupid thing. Anyways, going ahead, what should I do here? Can you take a guess? Add 5 it since somebody suggests. Okay, I'll make it 5. Does it work? No. Is the answer for the Patnam? Yeah, I think I can go for 6. That works. Run. Ta-da! Got the coin. Congratulations, guys. You solved the first level 1 problem of the world. There are 9 challenges in every world where you have to modify the equations. This is the next one. Oh, I went to the next world. More coins. Now there are more coins. You have to go to the next. Yeah, you have to play around. You guys, this is a very good game. Please play it. Which website is this? It's just search for Super Mario Quadratics. It's just us, basically. Super Mario Quadratics. Yes, Shashank. Yeah. Yeah, the answer can be complex maybe, but let's see. You can check it out. Okay. Anyways, visit the site. You'll get Super Mario Quadratics at some point. Check it out. Play it. You'll get into it. There's one for trigonometry also. That's where I learned the amplitude part. I did the trigonometry one, right? I think I did the trigonometry one. Trigonometry. We did the trigonometry or the marble slide, periodics. Yeah, it is from it is an it's an exercise which is on Patnam. Exercise based on Patnam. It's almost in the level of A1, A2, A3 of Patnam. A3 level of Patnam. That does see all Patnam problems are not hard. Some problems are very easy. Okay. So you can find this marble slide. Have you guys done this? I think I did it in another batch then. Only children play games. We are grown. We play with books. Okay, fine. So I know who's offended right now by that thing. I clearly know who's offended right now. Ashay probably. Okay, 1 second. Anyways, I'll launch. The question is you have to collect as many marbles as possible. Does it work if I launch? Do you think I'll get it? If I launch, do you think I will get all the marbles? This blue point, this purple point has to collect the coins. It's a marble. Success, done. It worked. No, it happened accidentally after class, sometime later. Okay. What about the next case? This is done. Launch. This is done, right? Next one. This time, what should I change the graph to so that the marbles go and hit this thing? The marble goes and hits those coins, collect the coins. These things will teach you a lot actually. What should I do to the graph? Look at the equation and I have to change something. Tell me at least what I have to do. Make it 2 to 4, change that 2 to 4. Okay, 4. No, not enough. See, the multiplication factor always preserves the roots. So do not forget that. 6 maybe, okay. Try 6. Let's give it a shot. We'll launch. I can add a slider, but we'll go with 5, I guess. Let's see. I'll launch. Yeah, 5. Congratulations, guys. You won. Okay, that worked. That really worked. But my point is you can try other things. There are more complicated ones. It gets much more complicated after this. This was the easiest ones. This is very hard. If I just launch, it won't happen. Here, we'll fail. If we just launch. So the question is, what should I modify the equation to collect all the stars? How should I change this such that I can collect all the stars? Spread it. How to spread it? Divide by 2, 5 by 2, remove half. Okay, remove half. Half will increase amplitude. And that might lead to clogging. Done. Clogging there only. All the ones reach the end there. The half was probably helping. I think one method is to, make it 4 times x. Okay. Sounds like a plan. Should I launch? I think I'll launch. Nah, still dumb. You need to introduce the half? Okay, I'll introduce the half. Somebody came up with a genius method in one batch when I did this. Okay, this is awesome. 3x, okay, 3x. Let's give it short 3x. Yeah, 1 star is below. I give 3x. Divide by 4, okay. Okay, intuitive. I'll launch. Let's see. Oh, whoa, worked. Awesome. Congrats, guys. Teamwork. Some of you contributed to the 3 parts, some of you contributed to the 1 by 4 part. But one of the most awesome solutions I had ever got was y is equal to 2. Just hope that it slides and goes and hits. Okay, and just slightly change the slope, like y is equal to 2, but give a very small slope, 0.00001 x plus 2. No. Very small slope, like launch. Oh, come on, launch. The slope has to be small, like very small. Yeah, this should work. The marbles roll. That was one of the solutions that we said. Oh, Murali said that. Okay, make it a line. Ah, Keaton also said it. Yeah. Okay. Yeah, I know. I didn't do anything. Okay, you guys can try this on your own, guys. Up to you guys. It'll teach you a lot about trigonometry functions. That's what I'm saying. The basics of it. There are many levels in this. It's called marble slide. It gets complicated and complicated as time progresses. It's for everyone, whoever wants to take up the challenges. Try it out on your own. Okay. Yeah, it's done using Desmos. Anyways, that is one thing. Now, continuing on. How many of you know about this? There is something special about number 41, which is, how many of you know about this figure? This figure is famous. How many of you seen this before? It's a common computer science problem given in computer science. Not related to Mario. It's related to something called, okay, you guys still see Mario. 1 second. Oh, now, what time is the quiz? The quiz depends on whether I finish the part. I'm still talking about that. Yeah, it's a mix. It's a mix. Anyways. Going ahead, can you see the pattern now? That pattern is very famous. It's one of the famous patterns in this thing. No, it's not one of the Millennium Problems. This pattern is famous. So you guys know prime numbers, right? And they don't have patterns. Prime numbers are very chaotic. You can't predict the nth prime very easily. Your computer gets stuck if you try calculating it. I tried doing it in the other batch. It could go up till 10 to the power minus 12. It's not easy. Prime numbers are very hard to get. Like the next prime number is unpredictable. But there was this guy by the name of Ulam. Okay, his name was Ulam. He was sitting in a math class and was bored, just like you guys today. Okay, and he was scribbling something in a lecture, and accidentally he discovered something amazing. Okay, I'll just show you what is it. 1 second. It'll take some time for me to click and open it, but it's about number 41. Something special about, not just number 41. It was actually about not fractals. Okay, can you guys see this? Can you guys see the video? Yeah, 1 second. Trying my best here. Wait, you know what? I'll switch to my Airtel. In the last 5 minutes of a class, I'm doing something like this. Okay. Yeah, it's about that. It's not exactly that, Shashank, but it's closely associated with that. Very well associated. It's Ulam's spiral. Yeah. 1 second. Better? Can you guys see the video now?
I want to talk about the number 4.
Video? I'll optimize if you want. Is the lag great, good? What is the situation? Okay.
41. 41 is a number which crops up in Garden of Rama, which when I was a teenage boy was just about my favorite book. I loved Arthur C. Clarke's stuff. He really enjoyed educating in a really subtle way. And so in this book, page 53, I checked.
There is a quadratic equation.
-1 plus 41.
Yeah, no. How bad is the lag?
So that's simply 1. If I put in a value of 2, I get 2 squared. That's 2 times 2 is 4.
Is it blurry, guys? Hello.
It is everything but a video.
Is it blurry?
Yes, sir.
Oh God, what happened to Airtel?
Let it be blurry. It's not lagging, and that's enough. Ayo.
Okay, blur is back. Blur is back. I'll play.
Minus 2 plus
so the
41.
equation I'll tell you is n square
43.
plus n plus 41. I think it's n squared plus.
And so on. I put in 3, and so I get 9 minus 3, that's
N
6 plus 41 is 47. And exactly as Richard Wakefield was saying in the book, what we're generating here is a sequence of prime numbers. Every number that we get for plugging in a value of n from 0 to 40
Imagine
is a
if there were
prime
a
number.
formula to get prime numbers just like that, plugging in n value. Okay, that'd be crazy, right? You just plug in some n value, like 5th prime, 6th prime, and you get the 16th prime. That would be crazy, right? I know it's not possible. I know it's not possible. But in this case, it's weirdly possible for some reason.
Now, if I plug in the value of n of 41, what I get is the value which is 41 times by 41, which is also a rather cute little symmetry to this problem. Okay.
So you've got this big sequence of prime numbers.
Which goes up to, for a value of 40, that goes up to 1600.
P versus NP, yeah, it doesn't still problem, but observe it. There's something interesting happening here, something subtle. Okay, I'll tell you why this works.
Okay, so we've skipped a few there. Okay, but they're all prime numbers all the way to 1601.
But you're going to show me something cool now, are you?
Yeah, I think so. What I'm going to show you is a little something that was first done by Ulam, Stanislaw Ulam, in 1963 while he was bored sitting in a presentation. And so he began just to scribble away. And I'm going to start with the number 41 in the middle of the page.
Currently, this problem is a famous computer science assignment, usually.
To scribble a spiral of numbers. So the next number is 42, 54,
Usually, yes.
57. So I'm just making a spiral of numbers. And at the end of that, I'm just going to get to just a couple more here. 60, 61. So what I want to show is how these numbers relate to our original series of numbers generated from the mathematics. Okay, so our first number in the series, for n equals 1, we get 41. And I've put that in the middle. Nice big circle. Okay, there you go. Then our second number is 43. Well, I've put that one up here. 47. Okay, it's down here. The next number, if I put in n equals 4, the next number I would find would be 53. That's up here. And then we continue and we find 61. 61
Where are the numbers?
Is down here. And so on. And so what we're discovering is that all of the prime numbers generated by the quadratic series are found on this diagonal, the lead diagonal of what we're calling an Ulam spiral.
And every number in that series, as you go down, is going to sit along this line here, is that?
Every number in the series is going to be on that diagonal line in this spiral. Now, this is neat because we don't need to start with 41. We could start with any number, and I invite you to try and do this at home. Start with any number, 1.
Start coloring all the primes. You'll see something amazing pop up in a spiral.
For example, 1, 2, 3. Red pen and just draw a circle around the prime numbers. 3, 5.
Observe this. If you go on shading,
but the fact is that there's this amazing pattern that just emerges out of nature, where you see these diagonal lines.
But this is what you get. Can you see some diagonal lines? Can you see some diagonal patterns which arise out of the
clusters? So if you keep doing this for enough numbers, then you end up with huge arrays of diagonal lines, which I'd like to show you. Not only on a Cartesian coordinate system where we're building a square spiral, but we could plot them on, for example, an Archimedes spiral, and then you get a fabulous pattern which will look a bit like this. Well, 41's really sweet because 41 is the biggest number which we can put into our
that is harder
original
to say
formula.
why the pattern comes up. But those diagonal lines are given by quadratic equations. All the diagonal lines in a Coulomb spiral are given by quadratic equations. And some quadratics, crazy thing is, some diagonal lines have more primes than the others, surprisingly. And turns out that n square minus n plus 41 is the, he says, is the one that generates one of the largest number of primes, one of the largest, the plus 41. That's the one that does it.
Which generates a series of primes. We could have used 11 or 17 or 5 or 3 or 2, and that would generate short series of prime numbers. 41 is the biggest one, which generates a series of all prime numbers. So this is why our hero in the book likes this series. He likes it because it generates 40 prime numbers.
But my point is, at the end of the day, simply shading and coloring. Somebody could come up with something like this, sitting in a class. Okay, just doodling and I don't know, simple stuff. Why does it happen is much more amazing, and there's a lot. But yeah, if you can solve this, good luck. Let me know if you can solve it. If you guys are done with it or something. Can you see this thing? Explain how it doesn't solve. So it generates. So for solving this thing, n is equal to this thing, whatever. The idea is you should be able to. So factorization problems comes at a non-polynomial time. The factorization problem of primes. And so the problem here is it doesn't generate almost every prime out there. It can generate only some, a sequence of them for a long time. Okay, you can go scavenging for primes along the diagonal, and sometimes there'll be gaps. The reason why he likes that is that's the only one that gives you primes continuously along a line. That's the largest continuous diagonal lines. There are gaps. You can see there are diagonals, but there are gaps between the diagonals. But that is the only one out there that gives a straight line with all of them colored. Yeah, some clues towards invariance. Murali, I used a big word, but you don't recall that. The idea is for this problem to solve this, you just need to know some ideas. Just speak to Nidhi and I think Satvik. Two of them were very close to solving it. Got some ideas. They got some ideas for how to go about it. Okay, fine, Amit. Yeah. Anyways, I can't give the quiz. I didn't finish certain things which I wanted to. You'll have the quiz next class. Okay. There is something I want to cover. I'll have to remove that question otherwise. There's one question which is not yet done. Anyways, I didn't see some of the messages. Yeah, I know. That's a hint. That's just a hint. But what if you move the axis smartly? There are some lines out there which, yeah. Keaton got it. Keaton figured it out too. Yeah. So you play around a little bit, you'll get some ideas of how to deal with it. Turns out the beautiful part about this problem is it works for any line, almost any line that cuts this thing. Yeah. Mithil, that's correct, yes, but I don't care about the answer. I just want the solution. I care about the solution. Okay, so good luck with this problem. Let me know what you guys think. No, Vita's relation, nothing. Super easy. It is actually very easy. But you need to know certain things here. First things first, you need to know something about quartic equations and cubic equations. Some knowledge about the roots of it. Some knowledge about the roots of that. You need some knowledge, little bit, not much, little bit. But I think you've studied that in the polynomials chapter, maybe, probably, I don't know. Okay, we can try others too, yeah. So anyways, there's no quiz today, sadly, because I have 3 slides to go before I can finish that problem. That problem is 3 slides away, which I need to discuss, otherwise it's in the quiz. So on Monday, you'll have a quiz, Monday or Tuesday, whenever the class is. Yeah. That's it. You guys can make a move. Yeah, sadly, there is no quiz. Emphasis on the sadly part. Yeah. Anyways, yeah. Okay. Bye, guys. Take care. That's about it for the day. If you guys have anything to ask, you can ask. What are we supposed to do for tomorrow's session? Please go through the instructions which I post on Google Classroom. Your 2 simultaneous equations. Yeah. Yes. Now you're thinking. Shashank. Yes. Okay, fine, Shashank Neyman. Yeah, Ashay, fine. Who and all send me messages? Yeah, Anvita, you're sure. Okay, what's the time for the coding class? It's most likely going to be 5 o'clock tomorrow, 5 in the evening, most likely, because I don't want it to clash with Aditya sir's class, which is from 1 to this thing. That's it. It's 1 to 4, I guess, 1 to 4 or 1 to 5 somewhere. Oh, the question is very simple. There is a polynomial graph given, which looks like that. And there's a line. Plot that polynomial, you'll see. And there's a line which is drawn. The line cuts exactly at these 4 points. A1, B1, A2, B2, A3, B3, and A4, B4. The question is, what is the sum of all the x components? A1 plus A2 plus A3 plus A4. No, morning 10 is not possible. Isn't it solving? Yeah, Satvika. Now you're thinking. Yeah, it boils down to that. Mithul, kinda, yeah. Any line, it works for any line. That's a special thing. This value remains fixed for any line. You can draw any line through that graph. It will always give you a fixed value. Yes, Murali figured it out. I think Murali and Mithul kind of figured it out. The first ones. That's the solution, yeah. Kind of the solution. That's why it's invariant, Murali. You can try any line, you can slice it with any line, and still beautifully, the sum becomes one value. The value does not change. It's like rotating a triangle by 120 degrees, equilateral triangle. If you rotate an equilateral triangle by 120 degrees, it remains the same. That's called invariance. It's a very important property of physics. Property in nature, we know. Conservation of energy is invariant. For example, if I were to, increase the time by 5 minutes, the energy of the universe does not change. And that's why your conservation of energy. If I advance the time on the clock of the universe by 20 minutes, the energy of the universe still remains the same. That's why you say energy is invariant. Yeah, Murali, yes. Yeah, that would be a good line. Yeah, now you can start thinking. You got the line, you got 2 equations. And what do you do when you get 2 equations? Yeah, the universe is unpredictable. Okay, fine. Wait for next. Murali's video is coming up next. If they are coming up also. Nadar's theorem, Nadar's theorem. I'm not going to introduce Nadar's theorem. I introduced it in volume 2 of physics. Usually.
Did it know ether?
Neither, neither, anything. It's pronounced both ways. Some pronounce it neither.
Anything PD pronounces that instantaneously becomes right.
No, the person is dead. The person doesn't care. Call me Prajawal.
You're insulting her memory. Ours.
Okay. Neither, fine. Neither's theorem. You can pronounce it as neither or neither, anything. Yeah, neither, fine. Sir, is the answer to the... Yes, brilliant. Yes.
Good books on wave theory, black body radiation, and what else? Ultraviolet catastrophe.
Okay.
Apart from Halliday, Resnick, Walker, and quantum.
You study thermodynamics for that. That's the problem.
Something without math in short.
No, the problem is you need thermodynamics to understand the ultraviolet catastrophe. So what went wrong? It's like a guitar string. You know, a guitar string can oscillate in any modes, right? Harmonics. The problem was these atoms were jiggling around with particular frequencies. They were oscillating with particular frequencies and emitting electromagnetic radiation. The problem is they never went to the ultraviolet range for some reason. The vibrational frequency never went to the ultraviolet.
How is it related to thermodynamics?
Yeah, because thermodynamics tells us how each molecule behaves, like how much percentage of the molecules in the system will have energy of so much, and how much another molecule. That's called actually statistical mechanics, but it's close to that. Thermodynamics tells you how much portion of the molecules
Maxwell's distribution law.
Yeah, I'm talking about Maxwell's distribution, and it's connected to the Planck distribution. Both have some connections. Okay, so you need to get ideas from there. You need to understand entropy also for that, why it matters. Okay, the entropy was the first hint for ultraviolet catastrophe.
Nidhi hates entropy after I speak so much.
Yeah, Halliday-Resnick. Go to Halliday-Resnick Walker. and go to entropy, the hint at quantum theory. That's the introduction to, that's the most beautiful introduction to ultraviolet catastrophe I know of. It's there in Halide-Resnick work. It starts with entropy and thermodynamics. Can we plot the equation? You can do it, yeah. I have a question here, Shashank, tell me, yes. One question that was asked recently, Murali, do you use a pipette as a straw for drinking? Yeah. Pipette, dude.
What is that? Sorry towards my ignorance. What is that?
Close enough.
A very bad organic chemist.
Yeah, I know. You guys can plot, yeah. Yeah. So, any other things? I think we'll talk tomorrow, probably afternoon when I'm sleepy. We'll have a Zoom call. Is my answer the Patna? Yeah. Murali and Keith, this guy Mithul got it. Both of them got it. That's correct. That's why it's invariant. Okay, one more doubt. Fine. Who? Which one? Who? What? Yeah, Amok. That's close. That's answer. That's the correct answer. But I need why. Amit, that's correct. Sakshi, that's correct. That's the correct answer. Yes. But the question is why? Why is that the correct? Why does it? You can try any line, right? Do you guys try every line? Every line you draw, it gives you the same answer, the sum. If it cuts at 4 points, it gives you one value always. Yeah, Desmos. All of you use Desmos. That's fine. That's the first method of solving mathematics, guys. Trying out things, cutting lines and seeing what value you get. In series, inductors in series. I mean equivalent inductance. That Henry thing, right? Oh God. 2 coils.
Am I bringing back bad memories still?
No, not exactly bad memories. I had a terrible teacher for that. So, anyways, you have 2 inductors in series. So first of all, what is an inductor? That's the question. So inductor is basically a coil which tries to reverse the oppose this thing, right?
Yeah,
so,
but in Halide-Resnick Walker, they somehow speak it in relation to DC.
In relation to?
DC current. They bring inductors into DC as
well.
By taking into the fact that when there is a resistance in the circuit, the current does not change instantaneously.
Yeah, if the current is steady, there's no point of an inductor. The inductor.
I know. They are saying when you turn on the switch, it raises steadily from 0 to some value.
That doesn't make sense for me because I is given by, if I'm not wrong, for inductor, what's the equation I've forgotten? D by dt times L times minus L times something. dV, I guess. EMF.
Yeah. EMF. For EMF, it is
L, minus L.
Minus L d by
inductance, yeah. Yes, Amit, that's correct.
Di by dt.
Wait. One more thing. So the question should be given in the RDS. It's just simple ratio. Why did they give it? It was not. See, the Putnam exam has many things in it. Amit, that's correct. Yeah. The thing is, a Putnam exam has many questions, different levels. Level 1, level 2, like that. There are level 6. There are six basic levels, and this was one of the lowest levels. Problems in the lowest level. It wasn't the hardest, but still it was given like a warm-up exercise. This problem, because it takes time to think. You guys had at least had this thing, Desmos, to get to know the answer and then think. You get the logic, right? And then think possible connections. The people solving it in this thing do not have tools, any of the tools. No, you did not use Desmos, I get it. But if you approximate, it's possible. You could use Desmos, you did not. So some of you tried it out. Okay, some of you didn't. It's fine. If you didn't, it's good. Yeah, it will work for those lines. Okay, fine. No, it's not 0. Okay, so Murali, we'll continue on. Yeah. So the idea is that,
EMF is equal to.
The inductances add up, right? If I'm not wrong, mutual inductances.
No, we have to prove that.
But to prove that, God.
They gave a hint. Think in the line of resistances in series.
Yeah, it just. How hard is to prove this thing then? Because the voltage varies by the same amount across both of them. V1 and V2, the split.
Yeah, because the same current passes.
Yeah, it varies by the same amount. So when you differentiate it, differentiation is linear.
No, why is it? No.
See, if you have V as V1 plus V2, okay. When you differentiate it, when you take the derivative of it,
yeah, it becomes derivative of V1
plus
derivative.
V2 done.
Yeah. Yeah, but we're taking voltage into account. The formula for EMF across inductor does not have voltage, right?
Which one?
The formula for EMF across inductor is minus L di by dt.
Di by dt, yes, di by dt. EMF is equal to
where
minus
does that
L.
have voltage in? How did it bring voltage?
EMF, see, okay. Wait, I got it. Where you're getting at. So, we're dealing with currents here, yes. dt, the inductance should add up.
I did it like this. This may be
I'll tell you the method. I'll tell you the actual method of doing it. You know the solenoid, right?
Yeah. Even I did it. I thought of like that.
Cut the solenoid in half. You got two inductors, and you know number of turns contributes to the haze.
Yeah. I did that much, but is it right to simply consider that the equivalent inductance will have the sum of the number of turns?
Yeah, that's one. No, that's assumption we're doing here. That's one way of proving it. But you know the solenoids, this thing. What is that? The whatever this is. It depends on the number of turns. It depends on the length between them, current, and all that stuff.
Yeah.
So using that, you can gain intuition. You can just gain intuition for it. I don't think it's the only way to go about it or solve it or something like that. But you can gain intuition out of that. So that's how I dealt with it. Yeah. So for inductances, yeah, I'll see if I can get something after 2 days when I get time. But
yeah, for a solenoid.
No, can you contact Amit sir by any chance? Just
yeah, sure. Yeah.
Just leave a message if possible. If you want the answer early only. Otherwise, it's fine. You can wait till 3 days. Yeah. Tell me.
Okay, so the formula for inductance of solenoid is nu naught n square A and L. Nu naught n square A into L.
Yeah. Area matters. Area of the loop matters. Length matters. Yeah. The length of the solenoid matters.
Yeah. So you're saying the length gets added up, and so does the number of turns.
No. No. It depends on n. N is, I think, number of turns per this thing. Length. That matters. This quantity matters. How densely it is.
Okay.
So if you go by that, because that increases the flux to the loops, more loops.
So for the final inductance, for the equivalent inductance, these two get added up from the individual inductance.
N by L gets added up when you add the lengths. It's the same for both of them. Since L matters the more, and you're adding lengths, so it's fine. It works. Okay, fine. Later. We'll try that tomorrow. Is that fine? After that sessions, yeah, we'll short as well. Yeah, so lengths get added up. Yeah. Why does Halliday-Resnick-Walker? Yeah, the Halliday-Resnick-Walker gives some questions, but if you use the extended edition, all solutions exist for the extended edition. But the extended edition doesn't have MCQs. Yes, Satvika, probably. Yeah. Some of you figured out the answer, but you need to find why does it work. And that hint lies in looking at the equation. Extended add solutions. Go to this thing, you get solutions. I think it has solutions. Go to Library Genesis, you'll find it. How to get the answer for the footnote without using Desmos? There is. Take a general line, y is equal to mx plus c. All of you forgot this part. Take the general line, y is equal to mx plus c, and start solving. Some of you took special cases, but it will work for, this is the proof for it, that it works for anything. Take a general case. Yeah, explanations are correct. Both of your explanations are right. Okay, I have a meeting at 7:30. So bye guys. I will have some food. So okay, we can talk while I have food.
You have some food?
Yeah, I'm not a robot.
Where does that go?
I don't know. You eat it sometimes, but I don't know. It just doesn't go into the muscles at least.
It does not go to the brain also. Where else does that go?
Yeah, I know. Doesn't go to the brain. Doesn't go to the eyes also. Sometimes can't see very well. Where and all. Okay.
Clear symptoms of old age.
Yeah, thank you. I have an aging brain. Brain develops till the age of 27. After that, you're dead. It's not good. You have time till 27 to learn new skills or do try what you want. It is said that, so that's the highest peak. Yeah, fine, Amit. Okay.
Yeah, have your food in peace.
Yeah, I'll see you guys. Bye-bye. Take care. I'll see you guys tomorrow. I'll post everything, whatever is needed on the Google Classroom.
Yeah.
Yeah, bye-bye. See ya. Yeah, you're welcome. Bye-bye. Solve the problem. Let me know if time for next class.